Picture this for a second. You are heading out the door for an important meeting. You grab the remote for your car, press the button, and nothing responds. Or maybe the television controller suddenly quits right in the middle of a game. Even worse, the flashlight you stored away with fresh batteries last month will not light up at all when you finally need it. Almost everyone has faced that moment. The first thought that hits your mind is simple. Is the battery dead, or is the device itself broken? What if the answer could be found in less than 1 minute using a tool you may already own? Most people never realize how easy this really is. Over the years, batteries start piling up everywhere. Some come from old electronics that stopped working. Others were bought in large packs and forgotten in a drawer. A few still sit unopened in original packaging. Eventually, you lose track of which ones still work and which ones are useless. Every time a remote stops responding, you reach into that drawer and gamble again. About a year ago, the frustration finally peaked for me. My wireless mouse failed on the exact same day as the TV remote. I grabbed what looked like a fresh AA battery from the drawer, slipped it into the mouse, watched it come alive for a moment, then die again less than a minute later. At that point, it felt impossible to know whether the battery was weak or the mouse itself was failing. If you already have one, this is the perfect time to pull it out and finally use it. First, understand one basic thing. Different batteries behave differently, but nearly every household battery works as a small container of stored electricity. That electricity is measured in volts. A fresh AA or AAA battery should usually show around 1.5 volts. A brand new 9-volt battery, the kind commonly used in smoke detectors, should read close to 9 volts. Even vehicle batteries follow the exact same principle, only on a larger scale. Instead of guessing, you can measure the real number directly. Begin by turning your multimeter to DC voltage mode. Batteries operate using direct current, so look for the V symbol with a straight line and smaller dotted marks underneath it. Many simple multimeters include settings such as 2 volts or 20 volts. For most household batteries, the 20-volt range is the safest option if you are unsure. Now look at the probes. One is red, one is black. The red probe connects to positive, the black probe connects to negative. Place the black probe against the flat side of the battery. Touch the red probe to the raised positive end. Then watch the number appear on the display. If an AA or AAA battery reads close to 1.5 volts, it is still strong enough for most electronics. If the reading falls near 1.2 volts or lower, the battery is likely nearing the end of its useful life. For a 9-volt battery, anything above 8.5 volts is usually acceptable. Drop below 7.5 volts, and problems become far more likely. Button batteries, the tiny round cells used in watches and hearing aids, often begin near 1.5 volts as well. But some devices stop working, even when the voltage only falls slightly below normal. Rechargeable batteries follow different rules. Nickel metal hydride AA and AAA batteries are considered fully charged around 1.2 volts instead of 1.5 volts like disposable versions. That means a reading of 1.2 volts is perfectly normal for rechargeables. But once they slip to 1.0 volts or lower, it is time to recharge them or replace them entirely. After testing the batteries in my own junk drawer, one thing surprised me more than anything else. Nearly half of the batteries I assumed were dead still had usable power remaining. Some actually performed better than brand new batteries from inexpensive bulk packs. A multimeter removes the guessing completely. It tells you in real numbers whether a battery still has life or whether it is truly finished. One quick test saves time, avoids frustration, and prevents perfectly usable batteries from being thrown away. But another question starts to appear once you see those voltage numbers. Does the display always tell the full story? Can a battery show a healthy reading yet still fail to power a device properly? That is where things become more interesting. Sometimes a battery develops what is known as surface charge. At rest, the voltage appears normal, but the instant a device tries to draw power, the voltage collapses almost immediately. You may have already experienced this yourself. The multimeter shows 1.4 volts. Everything looks fine. Then you insert the battery into a remote control, and the remote still refuses to work. That is when the real mystery begins. As a battery approaches the end of its lifespan, the chemical activity inside begins slowing down. Sometimes it can still appear healthy for a brief moment if it has been sitting unused. But the second power is demanded. The truth shows itself. Your flashlight switches on and fades instantly. The remote refuses to respond. The garage door opener struggles or fails completely. That is why people often become confused when a battery seems fine on a meter, but still cannot run the device properly. The important lesson is simple. Batteries should be tested under conditions similar to how they will actually be used. If possible, perform a loaded test instead of checking voltage at rest alone. Many ordinary multimeters cannot do this automatically, but there is still a way to simulate it. For AA or AAA batteries, you can temporarily connect a small resistor across the probes during measurement. A resistor between 10 ohm and 50 ohm at half watt works for this purpose. The setup imitates a battery powering a basic electronic device and reveals a far more realistic picture of the battery's true strength. I once spent hours trying to diagnose a friend's calculator because it appeared broken. In reality, the battery voltage without load was barely high enough to trick a quick test while still too weak to operate the calculator itself. The same principles apply to car batteries, only the consequences become more serious. Anyone who depends on a car for work knows the feeling. You turn the key and hear nothing except a click. Car batteries carry larger loads and much greater responsibility. People often refer to them as 12-volt batteries, but a fully charged car battery sitting at rest should actually measure closer to 12.6 volts. If the reading is around 12.3 volts, the battery is still usable. Drop below 12.0 volts, and weakness is beginning to appear. Anything under 11.8 volts usually signals major trouble ahead. The loaded test matters even more with vehicles. When the engine starts turning over, a healthy battery should remain above 10 volts. When I moved into a rental apartment, I found an entire kitchen drawer packed with discarded batteries. After testing them with a multimeter, nearly 1/3 still had enough energy left to remain useful. Since then, I've kept a separate container labeled half-used batteries. Devices with low power demand get those batteries first. Over time, that small habit saved a surprising amount of money. There's also a simple experiment worth trying. Gather every battery in your home, AA, C, D, 9-volt button cells. Measure each one using the multimeter. Very quickly, patterns begin to appear. Some brands maintain voltage far longer than others. Cheap, no-name batteries often lose strength rapidly. After enough testing, you begin recognizing which batteries are actually worth buying and which ones are not. The process becomes strangely satisfying because the multimeter strips away the advertising claims and reveals the honest truth. At some point, you realize this is no longer only about batteries. It becomes about understanding the small details that save time, money, and frustration in daily life. Every test replaces guesswork with certainty. You become more confident with your tools, your electronics, the devices around your home. A weak battery no longer ruins your morning unexpectedly. You can identify the problem before it happens. Sometimes battery-powered devices even seem unpredictable, working one day and failing the next. Voltage checks often expose the real reason. Temperature changes, dirty contacts, or aging components can all create drops in voltage or unstable performance. Maybe that sounds dramatic, maybe not. But anyone who has reduced grocery costs, repaired something instead of replacing it, or avoided an unnecessary trip to the store understands how quickly small savings grow over the course of a year. Knowing how to properly test a battery can leave more money in your pocket, create a little more order in your routine, and give you a much clearer understanding of how everyday devices actually function. And there is another side to this skill. Learning battery testing with a multimeter creates a foundation for much more. Today, maybe you are checking the batteries in a remote control, a car, or an electric razor. Next week, you may use that same tool to examine voltage at an old wall switch, troubleshoot holiday lights, or confirm whether solar garden lamps are charging correctly during daylight hours. Most problems in ordinary life are not solved through giant purchases or dramatic actions. Usually, they disappear through small improvements repeated consistently. Regular battery testing is one of the easiest places to begin. If your friends or relatives are not comfortable with technology, you suddenly become the hero when the smoke detector starts beeping in the middle of the night or when a game controller dies moments before an important online match. Armed with a multimeter and a little patience, you become the person who solves the problem. And the more often you use the tool, the faster and more confident you become. It starts with batteries, then curiosity takes over. Soon you experiment with continuity testing, resistance measurements, maybe even current testing as your confidence grows. Every small mystery you solve teaches you something new. Gradually, you build a mental understanding of how your home works, how invisible electrical systems quietly support comfort, convenience, and connection every day. That is practical economics in the real world, making resources last longer, getting maximum value from things you already own. Reducing waste in a time when too much is treated as disposable. Think back to what usually happened before. Maybe you tossed batteries away without checking them. Maybe you kept moving them between gadgets, hoping one would still work. Now you can test once and know immediately. No uncertainty, no guessing. Just a quick measurement and a clear answer. What once felt annoying and mysterious suddenly becomes simple and manageable, leaving you with more time and energy for things that actually matter. So the next time a stubborn remote stops responding, a smoke detector starts chirping, or a toy suddenly goes silent, you already know the next step. Pick up the multimeter, run the test, see the answer for yourself. And when someone looks surprised that you solved the problem so easily, just remember how straightforward the process really was. Everything began with learning how to measure battery voltage using a multimeter. If this information helped you or taught you something useful, you wish you had known earlier, pass it along to someone who constantly deals with dead batteries or unreliable electronics. A simple skill like this can save time, money, and frustration far more often than most people realize. Please leave your thoughts about this content in the comments below. Thanks for watching. See you in the next one.